Hey guys, welcome back to the reloading bench. So today we're going to be talking about loading some cartridges up for the Barnes monolithic bullets. And what sets them apart from the conventional bullets is that they're all one metal throughout. So it's a copper alloy of some sort. Conventional bullets have a lead core with a copper jacket on the outside. There's a lot of pros and cons to both, and we're going to talk about those. So first of all, I'm going to zoom us up on these bullets here. So on the left, you're going to see the Barnes monolithic bullets, and you'll see right away they're different because of the grooves that are cut out of the side of them. On the right hand side is going to be our Hornady ELDX, and they're 143 grain 6.5 millimeter bullet. So a brief description and history of the monolithic bullets in general. There was a lot of difficulty in the past making them work in rifles. So they have a few things going against them. Because they are a copper alloy, the metal's about 25% lighter than your typical lead bullet. So to have that mass, and mass helps us in the field, I kind of equate it to, if you're throwing a pea at something versus throwing a small stone. Let's say the pea and the stone are exactly the same diameter. The rock is going to hit stuff much harder. It's going to be less affected by wind. So that's what kind of mass does for us when we're talking about projectiles and bullets flying through the air. So when they started making these, there's a few challenges. One was the bearing surface. And when we talk about bearing surface, it's a surface that the barrel touches. So this whole length of bullet here is going to rub up against the side of your barrel when it fires. So when they started making monolithic bullets, there was a lot of copper fouling in the barrel because there was so much of that bullet that was in contact with the barrel. So not only did it copper foul, it actually increased pressures because there was a lot of friction there trying to get that bullet out of the barrel. So in the process of this, one of their fixes was to cut these grooves all around the bullets. And it did a few things. So it reduced the bearing surface, so there wasn't much bullet rubbing against the barrel. And it decreased pressures so you could fire them safely. But because again, that copper alloy is lighter than lead, if you want to get a heavy enough bullet, you do have to make that bullet longer. So it's just one of those things with monolithic bullets. If you have two bullets side by side that are the exact same weight, the monolithic bullet is going to be longer because it has to make up for that loss in the material that they use. So let's talk about it again. What are the pros? So there's no lead. They're very uniform. So they don't have to worry about that whole process about folding the copper around a lead core. Sometimes they're machined. So they're all made out of one material. So it's uniform from front to back, inside and out. So they fly typically very well. The other pro to them is that because they tend to hold together when they do hit an animal, they have good penetration. So depending on what school of thought you're looking at, that can either help us or hinder us, and there's a big debate on that. Some of the other bullets that I like to hunt with are Burger, and they kind of go away from the norm. They're designed to go in 3 to 4 inches and then completely blow apart. So you're not just putting a pinhole through the animal in the line of fire. It goes in a bit and then it hits everything kind of radially. So even though you may have missed the heart when it first went in, you may hit it with a shrapnel that goes around when it does fly apart. So I've actually started calling it deer soup. When I do open a deer up, I'm amazed at the performance of the Burger bullets. I witnessed this season alone probably half a dozen bang flops where the bullet hits the animal and they drop dead in their tracks. When I do go to gut them, it is just like jello inside. We had several animals this year where we counted over a dozen holes through the lungs. I took a picture of my daughter's deer's heart and it was literally blown in half. I actually posted that one to Instagram. So it depends on what school of thought you're going towards. Like I say, I've had very good luck with Burger bullets. So trying this is going to be something completely different for me. So what are the cons? And unfortunately there are a lot of cons with using monolithic bullets. The first is cost. When I bought these monolithic bullets, they were about the same price as the Hornady ELDX bullets, but I only got 50 bullets in this box and 100 in that one, so they are very expensive to shoot. If you're planning on shooting a lot at the range, it's dramatically going to increase your ammunition cost. We mentioned the weight before. There's no way to get around it. It is a lighter metal that the monolithic bullets are using, so you're not going to have that mass and all those advantages that mass will give you, such as less wind deflection, hitting the animal with more downrange energy, all that kind of stuff. So they are lighter. If you are going to buy a heavy monolithic bullet, for that same bullet you're going to need a faster twist rate in your barrel because it takes more to stabilize it. So from what I've read, that the guys that are interested in shooting these bullets and bigger bullets, they actually get a twist rate made for that monolithic bullet that conventional bullets won't work well in. So that's something to think about. We talked briefly about thermal performance, and I can't speak to it personally. I've read a lot of forums, and I'm very careful what I believe on the forums because there's a lot of kind of keyboard commandos out there. So some guys say they work great, others say that they hit the animal and it was like a pinhole going through them, they didn't expand at close ranges. So I can't speak to that personally. I do plan on doing some predator hunting this year so we can experiment with them a little bit. So hopefully soon I'll be able to give you some more information on that. The one huge drawback to these is the ballistic coefficient is greatly reduced. And it's greatly reduced because of these notches that are cut in the edges of the bullet. I bought a book several years ago, I think 2011 this came out. This was a book by Brian Litz, and he basically took every bullet on the market and he stated what their advertised ballistic coefficient was and what the true ballistic coefficient was. And it ended up that the monolithic bullets actually were the worst culprits for not having correct ballistic information on their websites. They may not have been doing that on purpose, but by cutting notches in the sides of the bullet, it just affects their aerodynamics, so you don't get the ballistic coefficient that you should. And some of the ones that he had listed here, the advertised versus the true ballistic coefficient was over 20% off. So as a shooter, I'd find that pretty frustrating because you would probably take a muzzle velocity like I do with a chronograph. You'd look at a ballistic program and you'd get your dial-ups for your different distances. And if it's 20% off, your dial-ups are going to be way, way off. So hopefully they've fixed this problem now. For whatever reason, the Barnes websites, it only lists the G1 ballistic coefficient. And the difference between a G1 and a G7 ballistic coefficient is the formula for a G7 coefficient is made for boat-tailed bullets, which is what both of these are. So I'm not sure why there is no G7 number on their website, but they list their G1 ballistic coefficient as 0.412. And just as an example, the Hornady ELDX I wrote down, and its G1 ballistic coefficient is 0.625, so much, much, much higher. So again, what's that going to do for us? It's going to cut through the wind better with a higher ballistic coefficient, and because it flies through the wind so much better, when we do hit an animal, it's going to dump more energy into that animal. It's not going to lose it through friction in the air. So that's another huge con for the monolithic bullets. The other problem with them is if you are getting a heavy monolithic bullet, again, they're going to have to be longer because they're not as heavy as lead. So they can't go this way on the bullet, so they have to go lengthwise. They have to increase the length. When you increase the length, you reduce the case capacity. So if I have my cartridge here and it's a much longer bullet, so I have to seat it that much further down into the neck, it doesn't leave as much room for gunpowder. So if we don't have as much gunpowder, we're going to get less velocity. So that's another problem with them. Having said that, I do like the non-lead idea, so we're going to give it a go. If this was my target gun, I wouldn't be thinking about this because I can't afford to double my cost in ammunition, or almost double my cost in ammunition. But because it's going to be our backcountry hunting rifle, we're not going to be shooting it as much as my target gun. We're going to give this a go and see how it works. So stay tuned. We hope to have some good information for you. We plan on going to the range tomorrow.